Hi there folks, another wee update regarding the tiniest workshed in Scotland, perhaps. A couple of wee changes I've made, and mainly today I want to talk a bit about safety. So let's have a wee look. Minor thing is that all my clamps now live up here. Makes me so happy. I love clamps. I love clamps a lot more than I love clamping. But that's just the story of my life. Main thing though is that after doing a prototype with some board, I got some 5mm ply from the DIY place. Went with my wee boy, we had lots of fun. Got this and I've cut a flush-ish surface for the router table, and that fact that this is nearing completion, at least to a usable state, prompted this video. So safety. I've got a bunch of safety equipment here. Mask, particulate filter with removable filters, you don't want to be breathing the dust. Hearing protection ×2, and eye protection ×2 because of, again, my little boy who loves to watch what daddy's doing in the workshop, so this is for him and I. Gloves, I've got many more pairs in a drawer down here. First aid kit as well, although really if you get to the point where you need that, you really also want to be relying on someone else to help you. So I guess the first safety tip would be, if you're using the dangerous stuff, which is what we're talking about today, don't do it when you're in the workshop yourself. And of course, never seal yourself into the workshop under any circumstances. So with now having a functional router table, in conjunction with the table saw, I've now got the two most dangerous power tools that you can use, with the table saw being the most dangerous by a fairly significant margin. So why are these things dangerous, besides the obvious fact of the big spinny metal blade? And that isn't actually the main danger. Well, let's talk about what a table saw and a router table are. You've seen one of these before. It's just a circular saw. Love this thing. This is actually a track saw. I took the shoe off of it and put in this track base, which goes onto my DeWalt track that you can see in that yellow and black box over there running down underneath the clamps. This is a handheld tool, obviously. Spinny blade pointing downwards. You take it to the material, and it has safety features, including this blade guard that runs around, and of course it's got a dead man switch, like most power tools do. In order to turn this on, I need to press that in with my thumb, and keeping it held in, then pull the trigger underneath. At that point I can let go of that and it stays in and it'll stay on. I don't have a battery in just now. Otherwise this would be spinning and making a noise, but as soon as I let go, it would turn itself back off. Same for a drill. Usually you have to switch it from neutral into forward or back mode and then keep the trigger held. Same for the jigsaw, it's in the case under there. Same for your lawnmower probably, which is fantastic. This is not the case, of course, for table mounted tools. And what is a table saw if not just one of these? Imagine you get this, turn it upside down so that instead of protruding downwards, the blade's protruding upwards. Fasten it to the underside of a table, cut an appropriate hole, you've got a table saw. That's all that really is. And the same is true for a router. You get a handheld trimmer router with the bits on the bottom spinning. Zzz. If you flip it upside down, attach it to the underside of a table, you've got a router table, and that is literally what this is, because this is a handheld trimmer. This is a completely separate third-party little basket clamp that you can wind up and down on that thread around there, and this is again a completely separate third-party plate. So that's a handheld tool that has been mounted to turn it into a table device. Now why would you do that? Handheld tools, they're obviously great, they're portable, they're relatively light, although this is quite a hefty thing. You can take it to where you need to do the work, you can get access to pretty much any part of the work pieces, and that's great, but there's a number of downsides. There's a lack of stability. There's the need to hold the thing. There's a need to keep the thing on. There can be difficulties in precision of measurement and guiding. You typically need more bits and clamps, and it all gets very complicated. What happens when you mount one of these to the underside of a table, or a trimmer to the underside of a table, is that you gain these huge advantages. You don't need to keep the tool switched on, and you have stability. You've got stability, of course, because you're borrowing gravity from this planet in order to ground the thing and hold it down. Then you can take the workpiece to the tool, feed it through, and make use of all kinds of things like a fence. That's the same thing, just bigger. Guides typically don't need to clamp as much. You gain these major advantages. And of course, the thing's just running once it's switched on. You can focus on using both your hands to get the piece of wood or whatever it is through the tool. So those two big advantages, it staying on and it being stable, are also the most dangerous aspects of both of these tools. What you need to do when you're feeding wood through either of these is basically need to keep three kinds of pressure on at all times. Down onto the table or the plate, into your guide, fence in this case for example, and of course through the cutting blade. That's the safest way. If you don't do any of those, or you don't do one of those, you create some serious risk, and it's not from the cutting blade itself, not directly. So let's think about this. Table saw, router table, incredibly versatile tools, incredibly useful, but the main danger is not from the spinning cutting blade. I'll tell you what the danger is in a second, but first let's talk about the blades. In the case of the router, it's a wee spinny bit, but going super fast. In the case of this saw, it's a massive blade, much bigger than that one there. My hand span is bigger than the blade on this one. The blade for the table saw is concealed in here. You can probably just see its teeth in there, but I've got another blade on the mitre saw beside me, which is the same size. It is 255 millimeters. I cannot encompass the span of it with my hand span. It's huge. If you look at those teeth and the size of this, the diameter of this blade, and think about the speed at which it rotates, the RPMs, you do the sums, and each one of those teeth is going around about 100 miles an hour or thereabouts, and that creates enormous risk, because if you don't feed the material correctly, then either one of these machines can change from being a tool that cuts through material into a different kind of tool, a gun, or maybe a missile launcher would be a better example. The material can catch on the blade, and then the blade will launch it at a significant proportion of 100 miles an hour. If that happens, even if it doesn't pierce your body, you can get a fractured pelvis, broken ribs, be knocked unconscious. You can get lethal blunt force trauma, and if it pierces your body, of course, then, well, you can imagine, but maybe don't try to imagine. The major risk is not body contact with the spinning blade. It is this thing called kickback, whereby the material is grabbed by that spinning blade and is launched at you. That's the big risk. Let me just take a wee sip of coffee. How do you mitigate that? Well, there's a number of ways, including that keeping safe pressure. A great way to keep safe pressure whilst keeping your hand clear of the blades with something like this, a pusher. The table saw itself has a number of safety features, including a riving knife and a blade guard. You can read about those elsewhere, but they are on the body of this saw somewhere, or they're on the underside, can't quite show them to you. But this is a major help, keeping that pressure. But you need to be guarding against kickback at all times. You can have an emergency very easily with any of these machines, and an emergency is less than you might think. It's if the workpiece starts to move in ways that it shouldn't. It starts to move out, starts to move in, rather than remaining parallel to the fence or whatever guide you happen to be using. It starts to bind, a bit of resistance as it goes through. Motor tone starts to change. All of these things are emergencies, and you need to be able to deal with them. With a handheld tool like this lovely thing, one of the things you could do is let go of the trigger. Then you have to freeze, keeping steady pressure, wait for the motor to wind down, then you're safe. With these though, the blade's running all the time. And if you obey your instinct, you sense an emergency, you might want to let go with at least one hand and go to turn it off. That's when you're in real trouble, because you won't be maintaining the down, guide and through pressure. Same on this. You can actually create the, or develop the emergency that you were worried about by your instinctive want to reach and turn the thing off. You can also find yourself in an emergency by the power going out halfway through a cut. That's a terror situation. Power goes out, you get a piece of material that is within, the blade, is within the material. And if you can hold steady when that happens, power's down, fine. But what if the power then comes back on? It's a momentary interruption in the supply. The blade starting up whilst it's within the material, massive risk of kickback, huge danger. So there are two situations at least that you need to have a safety protocol for. How do you handle power interruption, and how do you turn the damn thing off without releasing the even pressure and holding that's keeping you safe in the first place? And we have a gadget for for both of those things. It's called a no volt release, and there's one here built into the table saw. Apologies for the cramped confines, it's because I've got this stored on switch and off switch. And I can show you a better example because I've installed an aftermarket third-party one for the router. This is not plugged in, there's not going to be any noise. This is just a hypothetical demonstration. On switch and off switch, concealing that. This is built such that if the power supply cuts out, this goes off. And even if the power then comes back on, this will not go back on until you physically push that again. It's a solenoid that contacts an electromagnet. You can imagine how it's built. So if the power goes out mid-cut, this, and indeed this, will cut off and they will not come back on even if the power comes back up. That's the no volt release. When the voltage drops to zero, it opens the circuit and that's it until you turn it back on. That is a critical safety feature. The second critical safety feature is that when this is set up, its switch is at about the same height as that, or slightly higher. And it means I'm working up here, emergency, keep steady pressure, freeze, hold it still, and off it goes. That's the idea of a sort of thigh height no volt release switch. It gives you a really good fighting chance of getting out of those two types of emergency situation. If you're going to use stuff like this, a router table, a table saw, and they're fabulous tools. They let you do amazing stuff. There are some cuts that are, or some techniques that are either impossible or much harder, at least to do precisely with other tools. By all means use them, but always have the safety features in place. That is dangerous enough. That is even more dangerous. But the thing that will kill you, it'll be that. Give yourself every possible chance of going home safely. No amount of money is too much to spend on safety. Cheers.